Okay, so here's a quick video just to kind of jog your memory on flowchart proofs. You did do flowcharts last year in Integrated 1, and you were exposed to the flowchart proof itself, but you weren't necessarily held to the standard of having to do a flowchart. You could have just listed it out. We're going to formalize that a little bit more this year. So this is just a review of stuff that you should have been introduced to last year in your Integrated 1 class, or if you were a freshman, then you were definitely introduced to in your 8th grade math class. So one thing to keep in mind whenever you're trying to establish if two triangles are congruent to each other, you really only have 5 reasons that this could work. Now, we could have gone through and proved that all of the things match. So all 3 angles matched and all 3 sides matched, but that's kind of overkill. It's not really necessary. So my recommendation when you first start proving these is just kind of have the 5 written off to the side so you know what you're allowed to use. So we've got side, 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 angle, side, angle, side, angle, 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 side, and then the very special case of HL. And all of these are congruences. So, and remember, congruent means that they are identical to each other. They have the exact same side lengths, they have the exact same angle measures, everything. So keeping that in mind, hopefully this is kind of getting rid of some of the fog from last year. In the first row across the top, so I'm going to go ahead and highlight these guys so that you can see what I mean. And it really is just the first row across. So all of this row, you're going to want to be typically stuff that is a congruence statement. I know that seems kind of ridiculous to say now because that's all you've done so far, but this year we're going to expand on this. So in this row from last year, this would be where a certain side length is congruent to another side length, or a certain angle is congruent to another angle. This is where you discuss parts of the triangle. So in this row, we're going to discuss parts. You'll notice that I put 3 bubbles. And that's because based off of the 5 reasons that we have down here, you have to know 3 things. So we have to have 3 bubbles. Otherwise, we don't have enough information. So I'm going to go ahead and take a look at the picture, and I am going to start highlighting things that I see that I know are congruent based off of marks. And then I'm going to put those into one of the bubbles across the top. So I see these tick marks that I'm highlighting orange right now. I see that those are the exact same tick mark, which means as far as I'm concerned, those 2 are congruent to each other because that's what the markers mean. So that would be a side length. When you identify side lengths, you typically use 2 letters, a beginning and an end. So I am going to call the side length on the left line segment CA. It's congruent to, because of the markers, line segment TA. Now, I didn't have to do anything for that. It was already marked in the picture. If something's already marked in the picture using congruent markers, then my statement down here for my reason is that it was given to me. I didn't have to do any work for it. Okay, so now we want to take a look at the rest of the picture and see if anything else has been given to us, so we didn't have to do any work. Well, I see some angle markers too. So I see this angle marker up there that I've identified in green, and I also see this other angle marker that I've identified in green. Now, whenever you name an angle, it's always safer, I think, to use 3 letters, kind of a beginning, a middle, and an end. Now, wherever this green angle marker is located, so what letter it's located at, that's always going to go in the middle of the name. So when I name the angle on the left-hand side, so I'll start filling in my bubble over here. So this is angle. I'm going to leave a space here, and I want there to be an A in the middle of the name because that's where the angle's located at. Now, you want to think about the beginning and the end of that. So I'm going to go back, and I'm going to kind of trace that angle. I am going to start at C to go towards that angle A. So I'm going to put C first. So I'll go back to my bubble, and I'm going to put a C in there as the beginning of this thing. But then I still have to finish it. So I got to A. That's why A is the next one in the name. Then I have to go down to get to S. Notice that I want to trap that angle marker inside. So I'm going to put an S here at the end. So the angle on the left-hand side, I'm going to call CAS. This is going to be congruent to, and then I'm going to follow the exact same format. I'm going to leave a blank. I want A to be in the middle of the name. I go back to the picture and think about the motion that you use to be able to name the angle on the left-hand side. I kind of started out at the edge of the triangle, so I'm going to do the same thing. So I would start at T this time, go up to A, and then go down to S. So I would have TAS as the name of my angle. The reason why those are congruent, well, there was a marker in it. So I was told flat out, and this was given. I didn't have to do any work for it. Then, and take a look back at the picture. I'm supposed to have 3 things. Well, I technically do. It wasn't given to me, the third one. You have to do a little bit of work here. But if you take a look at this, we have these 2 triangles. We've got the one on the left-hand side that we used CAS for, and then the one on the right-hand side that we used TAS for. They both share that line segment AS, and you can even see it in the name of the angle. So if I take a look back at the middle bubble, notice that I have an AS in each one of those bubbles. That's an indication to me then that I have that line segment that they share. So I'm going to go back to my picture and I'm going to mark that line segment in blue so you can see it kind of splits the left and the right hand side. I am going to say that those 2, or that line segment, is congruent to itself. It sounds kind of silly, but you still have to be able to introduce it into the proof. So I'm going to say line segment AS is congruent to line segment AS. It's congruent to itself. And when we say that, think about a mirror. You are the same person when you look into a mirror. It's the same person that everybody else sees. This is the reflexive property. And now I can take a look at my picture. And then my job is to figure out, well, which one of these 5 is it? So which one of my reasons is it? And one of the things that I recommend to people when you first start doing these types of proofs is just kind of eliminate stuff. We know stuff that isn't going to work. So let's start crossing stuff off. It can't be side, 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 because I would have to have 3 sides identified within the bubbles, which I don't. So it's definitely not SSS. SAS, maybe, could be, because I'd have to have 2 sides and 1 angle, which I do. Okay, so maybe SAS. ASA, no, you'd have to have 2 angles identified, which I don't. Angle, angle out, angle, angle side, nope, I don't have 2 angles identified. HL, nope. Remember, HL, although the name only has 2 things in it, the H implies that it has a hypotenuse, which means there's a 90-degree angle in here. And if you take a look at the bubbles that we have across the top, we didn't say that anything was 90 degrees. So process of elimination tells me this is side, angle, side. And if you take a look at the picture and you try to do side, angle, side, one of the things that I recommended to my students last year, and something that you might want to consider, it really might help you determine this, is the 2 triangles that you're taking a look at start at an empty angle. So something that doesn't have anything at it at all. So on the left-hand side, I would start at like C. Then I'm going to trace across my markers. So if I go across here, I'd be going across a side first. So there's an S. Then I would have hit an angle, and then I have to finish going across that side that was marked, and then I would finish my triangle. Notice I only identify the SAS when I'm going across markers specifically. And then just check and make sure that you can do the exact same thing in the other one. So starting in the same relative location, starting at the T, I would go up and I would go across an S. I landed at an angle, and then to finish my loop, I'd go across another S, and then nothing was marked. So to me, it does look like I have side, angle, side. So with that said, I can now say, I know what my reason is. That's not the point we need, or that's not the main issue here. I still need to be able to name my triangle. So at the bottom here, I'm going to go ahead and say, okay, this is side, angle, side, triangle congruence. It might help to write the triangle symbol for yourself because now we know these have to be triangles, have to. And then may as well just follow the order we did when we just traced around it to make sure that it actually worked. So CAS is congruent to, don't forget the triangle symbol, TAS. So hopefully that looks familiar. I do have one more question on the next slide. Okay, so same idea, maybe a little bit more complicated, but hopefully with your memory jogged, this might be a little bit more familiar. So I'd recommend pausing it and then seeing if you can do it. So I went ahead and I filled in the given information. Just kind of like the previous one, though, you hopefully remember some vocabulary words here. We also have one more thing that we need to be able to identify here. And in this case, it's not reflexive. It's actually vertical, which is something you and I are going to be reviewing in Chapter 2. Vertical angles are going to occur kind of right in the middle here at angle P. I'm not going to call it angle P though because there's way too many things going on there. And I'm also going to use different markers. And as soon as I mark it in my picture, I'm going to go immediately to state it in my proof. So this is an angle. You want to make sure that the P is in the middle of the name. So I'm going to go NPM for the one on the left. Make sure that you match the other. Ooh, that's not a triangle, that's an angle. Just match the order as well. So NPM, so let's do TPR. And your reason for this is vertical angles. Okay, at this point now we have our 5 kind of listed off to the side that we need to eliminate. Okay, so taking a look at these, I'm trying to figure out what I'm not going to have. So I'm just going to look at the bubbles, and I see a side and 2 angles. Okay, a side and 2 angles. It's not SSS, it's not SAS. The angle isn't 90 degrees, so I'm going to get rid of that one also. Okay, so it could be angle side angle or angle side. Well, if you take a look, you want to look and see where the side is in relation to the angles itself. And in this case, the side is trapped between the 2 angles. You see that the blue mark is in between the orange and the green. If it's trapped between, then it's angle side angle, because you see the side's trapped. So I'm going to go ahead and put angle side angle, triangle congruence here. And then just be careful with your order. So I think I'm going to, let's see how we can trace this thing. So I'm going to start at an empty angle. So I'm going to start at N. I think I'm going to go N to P first. That's an angle. Then across, there's a side. I landed at an angle and then finished my loop. So I went N, P, M. So triangle, N, P, M. Congruent to, let's find the name of the other one. So start in the same relative location and start at an empty angle. So start at T. I went to P last time, so I'm going to go to P. So T to P, there's an angle. Went across, there's a side, there's an angle, and then go ahead and finish my loop. So it looks like it's going to be TPR. Okay, just a quick little review. I hope it helps.